Hello everyone. In this video we will review everything you need to know to graph linear equations. So to begin, we graph linear equations on the rectangular coordinate system. You may remember that this is a way of graphing points, lines, functions, and we begin with a pair of axes. We have two overlapping number lines. We have one that runs horizontally, and then we have one that runs vertically. These two axes divide up the plane into 4 different quadrants, and then each quadrant has points in it with either positive or negative values. So quadrant 1, we have points which have positive x-coordinates, for example a 3. Okay, so it's on the right hand side over here where all of the positive x values are, and then it's above the x-axis, up where the positive y values are. So something like 3, 5 would be in that quadrant. Okay, and then quadrant 2, all of your points have negative x values and positive y values. Quadrant 3 is all of the coordinates or points with both negative values, and quadrant 4 is all of the points with positive x values and negative y values. Other terms, the origin, that's the point at the very center. That's the point 0, 0. And then we have an x-axis and a y-axis. Alright, a review of how to plot points. So to plot the point 5, negative 3, you need to know that the first number represents the x value, and the second number represents a y value. And you start at the origin, and you move to the right or the left to whatever number you see for the x coordinate. Alright, so we're going to go on the x-axis to where x is a 5. So that's to the right. Okay, right here. And then we find on the y-axis where y is a negative 3. That's down here. And then if you picture lines through those points, then you find the place where they intersect, and that's your point. Right, now you don't actually draw any of that work when you're plotting points. You usually just skip to the point itself. So we would just draw the final answer as a point at 5, negative 3. 0, 4, we would go to 0 on the x-axis, that's here, and then we would go up to 4 on the y-axis and plot the point. Alright, negative 3, negative 2, go to negative 3 on the x-axis, negative 2 on the y, plot the intersection. Alright, negative 2, 0 is negative 2 on the x-axis and 0 on the y-axis, you stay right there. And then 2, 6, here's 2 on the x-axis and 6 on the y-axis, so your point 2, 6 is right there. One thing that we can do when we know how to plot points is graph different equations, functions, different relations on a graph. So in this section we will look at graphing linear equations in 2 variables. So our 2 variables are the x and the y, and then we have equations which algebraically describe the relationship between x and y. So here's an example of a word problem that represents a situation with 2 variables. Suppose you get offered $6 to stand on a street corner and hand out flyers for a restaurant, plus an extra $2 for every customer that brings your flyer into the restaurant and orders a meal. So we could use an X and a Y to represent the two things that are changing or unknown in this situation. One of those things is the number of customers who order the meal with your flyer, and then the other is the amount of money that you make. So you can see how much money you make depends on how many people go into the restaurant with your flyer. So there's a relationship between those two values, and then we can write an equation to show that relationship. Okay, so let's do that now. Let's write an equation, and it may help to begin with looking at some specific numbers. So let's say that 5 people go into the restaurant and order a meal. All right, well, how much money would you make? Well, you get $6 just for standing there passing out flyers, regardless of how many people enter and order. But then to that, you also get $2 for each of those 5 people. So that's 2 times 5, right, or $10 for those 5 people. So altogether, $16. All right, now to write an equation, you just need to go back, and we want to make this a general equation that represents any number of customers and the amount of money. So instead of using this specific 5 and the specific amount of money, 16, we just replace those with variables. So 16 represented money, that's the Y value, and 5 represented the number of people, that's the X. So your equation would be 6 plus 2X equals Y. You may also remember that often you'll see the Y value on the left, so we can just reverse this and write the equation Y equals 2X plus 6. Alright, now let's say we want to find some solutions to the equation. So this time a solution is an X and a Y, a pair of numbers that together make the equation true. So we need an amount of customers and the corresponding amount of money. Well, we have one of those solutions. We know that if there are 5 people ordering a meal, then you will earn $16. All right, and let's do maybe 2 more solutions. So let's just choose some X values, and then we'll see how much money is made. So let's say 0 people order a meal with a flyer, and let's say maybe 2 people do. Alright, so now to find the solution, you just want to substitute that X value into the equation and then see what the Y value is. So for 0, we have Y equals 2 times 0 plus 6. So you're not making any money from customers ordering, but you still get your $6 for standing there handing out flyers. So you still get $6. And then similarly, if 2 people order, then you get $4 for them plus your $6, or $10 altogether. Alright, so let's say we want to plot the solutions to that previous equation, Y equals 2X plus 6. Alright, so here are our points, our solutions. And we can plot those on this graph. Alright, now 516, notice this graph only goes up to 10. Alright, so I might not want to actually plot that one. Another option would be just to change the scale of the graph. Maybe I could go by 2s or something instead. Okay, so it would be like 2, 4, 6, etc. instead of 1, 2, 3. But for this, our purposes, I think I'm just going to skip that 516, and maybe I'll do a different point instead. All right, so let's say 4. Let's see, that's going to be too big. Let's go with 1 customer. 1 person orders. All right, so you get your $2 for that person, plus your $6 for passing out flyers. Alright, those should all fit on this graph. So we have the point 0, 6, and that's here. All right, we have 2, 10. And 1, 8. All right, now you may notice that all of these points actually seem to line up on a line. So what we have is the graph of the equation, and this is a way to geometrically represent every pair of numbers that's a solution. If I were to connect these points in a line, let's see if I can do this. Okay, it's probably a little bit off by the time I get down to the corner here, but it seems to match my 3 points at least. Alright, so now I have a line which would continue in both directions and represent all of the possible solutions. Alright, so I didn't actually plot this on here, but I would have, alright, maybe your next one, maybe you have 3 people, and that's going to be $12. Now that's off the graph, but it is on that line. So eventually that line will hit all of the different solutions. Alright, so we have talked about a linear equation in 2 variables. We've talked about the fact that it's an equation and that it has 2 variables. What does it mean to be linear? Well, if we can write it in this form, ax plus by equals c, where a, b, and c are real numbers, that's what makes it a linear equation. Other things to notice. The exponents on the x and y are both 1s. Right, there's nothing written, so that's assumed to be a 1. And let's see, we can also rearrange this. So if you have some of these terms, like maybe the ax is over here and maybe the c's on the left, right? If we can rearrange something to get it in that form, then it's still a linear equation. This form is called standard form, so you'll definitely want to remember that. Alright, how about the equation y equals 2x plus 6? Is that a linear equation in 2 variables? Well, I need to make it look exactly like ax plus by equals c. So I need the y is in the right spot. That's over on the left-hand side of the equation. The x term I need to move over, and then I do have a number, the 6 on the right, that does represent the c. Alright, so I just need to move the 2x over. Okay, so if I subtract 2x from both sides, then we get negative 2x plus y equals 6. Okay, so this is in standard form. The a, the number in front of the x, is negative 2. B, the coefficient for y, is a 1, and then c would be 6. So yes, that is a linear equation in 2 variables. Alright, I'm going to stop there and pick up in another video. So in this video we've talked about the preliminaries for graphing linear equations, primarily what is the rectangular coordinate system, how to plot points, and how to recognize whether or not something is a linear equation with 2 variables.